Hello everyone, hope you're fine. Hope all of you are still awake after the lunch. Today I'm here to talk to you about the power of federated plugins in Flutter ecosystem. So first I wanted to do a quick survey. All of you Flutter developers or some of you are just Android developers for now? So if you're only Android, raise your hand. Okay, so Flutter developers everywhere, great. It's going to be way more easier for you to understand what I'm saying. So a quick introduction, my name is Guillaume Bernos. I'm working at Invertase on the Flutter Fire project. So if you have any question about Firebase or Flutter, I should be able to answer them, so don't hesitate to find me. And I'm going to start with this screen. So this screen, it's probably an error that every Flutter developer has seen at least once in his life. It's an unhandled exception, missing plugin exception, and no implementation form for the method on this particular channel. So during this talk, I'm going to explain to you why this method happens, how you can better understand what is happening in the underlying system, and maybe help maintainers and developers of open source projects to report better errors. If you get this, probably it's maybe their fault, maybe your fault, but after this talk, you should be better able to troubleshoot this kind of errors. So the outline is pretty simple. I'm going to explain to you what is the difference between the package and a plugin. Then what is a federated plugin, so what is the difference with a simple plugin. And then if some of you want to try, you should try to write your own plugins. I mean, you probably have some ideas, some SDK that aren't ported yet to Flutter. I will show you some quick tips on how to write a federated plugin. So let's start. So first, what's the difference between a package and a plugin? So first, what is a package? Packages aren't specific to the Dart and Flutter ecosystem. You have it in all ecosystems. So for instance, in JavaScript, you have the NPM repository where you can find a lot of packages. And on Flutter, it's on pubdev where you can, with a quick search, find any kind of packages also. So a package is something that enables the creation of a modular code that can be shared easily. So you create a Dart package by creating a pubspec.yaml file, quite easy, with a name, description, some dependencies, and a lib folder with a package name.dart file. With that, you can publish it on pubdev, but you can also just keep it locally and use it in different projects. For instance, if you have an application and you want to extract the theme of your application in another package to be sure that there is no business logic in your theme part and that it can be reused in other projects, well, you can do that as simply as this. So that's a package. But it doesn't tell us what is this error. This error usually is happening if you are using native part of your application. So you have the Flutter part of your application, and you have the host that is running your Flutter part. They are communicating with a platform channel. So a Dart package depends only on Dart. If it's a Dart package, it often can be also used in a Flutter app. Maybe not for server stuff or stuff like that, but most of Dart package can be used in Flutter packages. Plugin package, on the other hand, combine Dart code with platform-specific code. So it can be alongside your lib folder, you'll have, for instance, an Android folder or an iOS folder or macOS folder, and in it it will contain native code that will be added to every app that contains your package, your plugin. So you have Kotlin and Swift to target mobile platform, Objective-C and Java if you're not that lucky, C and C++ if you target desktop platform. You can also combine Dart codes with Dart FFI. I have not a lot of experience with that, but it's something that also you can do. So often this error means that you have used one of the best features of Flutter, which is auth reload. You have added a package that depends on native. So for instance, you have added something to take to use the sensor of your telephone, of your phone. So you are going to need the tilt of the phone for your application. So you want to add that. But Flutter doesn't know anything about the position of your phone. So you have to call like native code in order to be able to get this information. And when you will add a package, it will probably show you this error because you have just added native code that hasn't been compiled into your application yet. So one of the easiest way to check that is close your app, restart it, and it should compile the native part of this particular plugin into your application, and you should be good to go. So how does it work with Platform Channel? So this is a simple graph to show you a bit how it's working. So to communicate between the host and the Flutter app, you will need a platform channel. So a platform channel is just a bridge that is open between Dart and whatever host you have. So for instance, in iOS, the receiver of will be in Objective-C or Swift, and for Android, it will be in Java or Kotlin. So since we cannot send Dart object directly because it doesn't make sense, for instance, if I send a list view to the host isn't going to be able to populate it with objects. So often you send messages that will be containing like booleans, ints, strings, stuff like that. So it will need to be serialized from the Flutter part and deserialized in the iOS part or Android part. There are two types of platform channel. There is like method channel that can be used to send and receive a response. So you send a message, you wait for the response, and you get it. And there is event channel that will open a stream. So it's, for instance, in the example of getting the location of your user, you don't want to send like, where's my user, where's my user, where's my user. You just open a stream and you will get all the information directly. So yeah, that's how it works. As I've said, simple plugin will have all their code directly in one package, which means like, for instance, if you have a sensor package, you will have like the lib, the Android folder, the iOS folder directly in it. But there are some limitations about having all the code in some place. First, the number of platforms supported by Flutter has grown a lot, which means that now you can support Android, iOS, web, macOS, Windows, Linux, and probably they will add other platforms soon. So this is really good, but for plugin developers, it had become really hard because you need a lot of knowledge in a lot of different languages. So for instance, you have maybe someone that is really good in Kotlin but have no idea how to write like a Windows package. That's me. So it's really hard. So as the platform or the ecosystem has developed, a lot of packages still has like only Android and iOS compatibility and like web support or Linux support or stuff like that. So this was the limitation of simple plugins because like everything was in one package. So you need like one person to have the knowledge of all the languages just to add one feature, which can be like really hard. So the Flutter team came up with a federated plugin concept that helps to solve all this problem. So a federated plugin is basically like one interface for the plugins and one interface for the user of the plugin. So I'm going to show you quickly how it looks in the URL launcher. So open the file. So as you can see on the left, we have the URL launcher package. So we have all the details. So when you're adding on your pubspec.yaml URL launcher, you can see that this is this package that will be added. So this is pubspec.yaml. So this is a file that is describing everything in the package. So we have the names, the description, where you can report issues. So this will be all the information you can find on pubdev. And here you will have this part, which will define for each platform where you have to find the native code to make it work. So as you can see, for Android, it's URL launcher Android, and for each platform, it's practically it. So that's it, but if I go a little bit deeper in the lib folder, as you can see, we don't have any like Android or iOS folder right here. And if I go on right here, for this method launch URL, which is exposed when you want to open a URL in your Flutter app, you can see that we are using the URL launcher platform.instance to launch the URL. So we don't do anything native here. We're just using an interface. And this interface is basically the one that all implementation will have to implement in order to be recognized. So we can find right here. So if I go up, you can see that this is an abstract class, which is a platform that extends the platform interface. I will explain it a bit, but basically a platform interface is something that makes sure that you have implemented correctly every method. So, and there you have the launch method that will take like all the different parameters and will just throw an implemented error. It's just the interface that all the underlying plugins, so Android, iOS, Windows, web, will have to implement in order to be fully supported. Why do we separate URL launcher from the platform interface? It helps us like change the implementation if we want of all the plugins without changing the front-facing implementation. So for instance, if some API change, I can change all the plugins are going to talk to the platform interface, but my user, the user of my plugin, will have nothing to change. So it helps avoid breaking change. It cannot help all breaking change, but it helps a lot. But now, if we go in the Android part, we can see that on the URL launcher Android, we have something that extends the platform that we have just defined. And here we override, and we can see that we are sending a message through a channel. So here, we're finally communicating with like the native part. So we are 3 packages deep. We went through URL launcher platform interface, and then URL launcher Android. That's why it can be confusing at first, but once you have everything set up, it's quite easy. So I'll go in the Android part to show you where this message comes. And as you can see here, I have a method call handler, which is like pretty easy to set up. And here you will have a simple switch on each method. So as I can see here, I call the method launch, right here. And here, the launch method we call the onLaunch method that will pass everything and do anything native. So with here, you have the full workflow on everything is processed through all the different parts and all the different packages. So it's a lot of files. you have to go through like 4 and 5 files just to understand how the request is processed. Once you have that, it's really easy to maintain because I don't have to touch URL launcher Android if I only make a modification for iOS, for instance. So yeah, that's basically how it works. So as I've said, the platform interface is different than the user-facing interface, and it helps avoid breaking change a lot. So as I've shown you, you have in the perspective camel all your different default package. And that brings us to endorsed plugin versus non-endorsed plugin. So there are a lot of ways of thinking to non-endorsed plugin. It can be a way to extend a plugin that is not supported anymore. For instance, you have a plugin you love. You don't want to fork it and having to maintain the fork or something like that. So you could like just create the Linux part of this plugin, for instance, and say that you are implementing, for instance, Firebase Auth. Say you are implementing the Linux part, and you could use it alongside the official plugin without having to change it. So that can be really useful if a plugin will never support Linux, but you still want Linux, so you can implement it on your side, still get all the new benefits of the plugin being updated, but you have the Linux implementation on your side, on your own. But user will need to edit manually. So yeah, and it can be for if you like a platform. I also seen this for Stripe. So Stripe for web was in beta for a long time, so they were using non-endorsed implementation. So you had to add Stripe for web manually, but then it was working. But it was a way of saying, yeah, it's not perfectly ready. So you have different way of thinking about it. In my case, for Flutterfire desktop, we use it to add a full Dart implementation of Flutterfire. So it's something that a lot of persons have asked in the community. It's actually really hard because Firebase is huge. So the official Flutterfire package will rely on the underlying SDK. So we take the Android SDK, the iOS SDK, the web SDK, and we wrap them. But we also have a beta Flutterfire desktop part. in which we have Flutter desktop, yeah, in which we have like some packages that are re-implemented to only rely on Dart calls. So it makes them compatible on all platforms, so Linux and Windows, which aren't supported officially by Firebase. And it's pretty easy. So as you can see, we have like the Firebase out desktop part, and in the pubspec.yaml, same thing, we say we implement Firebase out, and we say that we implement it for Linux and Windows. And then you just need to, I'll just take back, you just need to add it to your dependencies. So you can see that I'm adding Firebase auth and Firebase auth desktop. And for the missing platforms, it will use the one from Firebase auth desktop. So same underlying method. If the front-end package changed, but the underlying front platform interface doesn't change, this one will still work. So it's harder to maintain, but it's a good way of adding features to packages you don't control. So yeah, that's it. So now, how to write a federated plugin. So there are a lot of steps. I'm not going to do a class on Objective-C right now. We don't have time. But I will tell you some tips on how to design effective cross-platform API, because it's something that can be a real struggle when you're starting, because you have to think functionality first, then API. For instance, if you do like a location package, you might have different way of thinking about it. So you may want to get the location of your user. You may want to get the last known position of your user, and you might know if the user has given the permission. So you could have, like, for instance, 3 different API, or maybe you can like group the first 2 API to have just get location with like a flag, last known, false true. So there are a lot of way of thinking about it. So I will think like, first try to think of all the functionalities you want to implement in your package, and then try to come up with the API that is the simplest as possible, because the less surface your API will have, the way easier it will be to document, the way easier it will be to adopt from your users. Something that you can say, like, instead of adding like arguments for everything, you can also add specific arguments that will be ignored for most platforms. So for Firebase app check, we have a web reCAPTCHA seed key that will be ignored on Android and iOS, but will be only used on web. So that could be a good thing to only have like the same API for all the things, even though it's ignored on most platforms. Yeah, you can also like create a method only for this platform. So sign in with pop-up is only compatible for web, because it would like create weird thing where you will have to make a result nullable. So you still have to think like, how can I make it easy to understand for most people? So this API was created when web wasn't this popular in Flutter. Maybe today we will do it differently. But yeah, you can also like separate and create specific function only for specific platforms, and just throw an exception on all the other platforms to be sure that people don't use it. You also have to think about the native call. So this is a weird part, because, for instance, for getting your location, you could think like, I'm calling get location. Everything happens in the native part, and then I get my location back to Flutter. This is nice, but it makes all your code reliant on the business logic of your plugin being written in native. What you can do is separate like multiple native calls and putting all the logic in your Dart code, which means, like, for instance, for getting location, the user will just do get location, but the platform interface will maybe call a first time, has the user permission, get the result back in Dart, check if what I have to do depending on this result, then call another thing to native, get the result back. So it makes easier to write all the logic in Dart, because you will be able to reuse it between like maybe Android and iOS and web, instead of writing all the business logic in native, where you will not be able to reuse it because you will have to copy and paste between different languages. So yeah, something to consider, especially if it can help you to keep your code really simple in the native part, which is always nice, because you you don't know what can happen with like an Xcode weird error, stuff like that. Then once you have think about your API, you can create the platform interface. So there is a plugin platform interface package on PubDev that help make sure that the platform is properly implemented. It's created by Flutter official team, so you can use it. It's using all plugins. So basically, you have just to write this code, which is a placeholder code that you can kind of copy and paste everywhere. So it works. And then you have a lot of useful tools that can help you like move really quickly. So one that is really nice is a very good Venture CLI, very good CLI just. With like just one single line, you can have all the placeholder plugins created for all the package, which can help you win a lot of time. So I will definitely consider using that if you're creating a new plugin. You have Melos, which is a CLI tool to manage monorepos. Lucas Spidon has done a talk yesterday about it, so if you want to know more about it, you should check his talk, but basically it allows to have every dependency properly managed. So when you are working manually, you have, for instance, you do a new version, you will have to up your launcher Android version number, and then you have to bump the URL launcher number, which can be hard. You have to manage changelog. Basically, Melos allows you to automate everything, so it's really nice. It helps with local development, so I will definitely consider using it. The last tool is Pigeon. So I'm a huge fan of Pigeon. Pigeon is basically a tool that helps you define your platform calls directly in Dart. And it will create all the calls, all the native files to parse this. So when I was talking that you cannot send Dart object to native, this is kind of a way of going around that and send Dart object that will be parsed by Pigeon and passed on the native side also by Pigeon. For now, it only supports iOS and Android, so I hope it will support more things. It doesn't support even channels, but it's really valuable. We're using it on Firebase Core for the moment, and it's been like quite really great. So yeah, and it also you can, if you already have an existing plugin, you can add it to your existing plugin. You can have both sides and migrate slowly to Pigeon. So that's really nice. So I will probably use that if I was to create a plugin today. And that's it. Do you have any question? No? Yeah?
When you work on a federated, for example, I tried one time to create a plugin for Android and iOS to improve the check connectivity.
Okay.
And I use on Android one library that I know from my time on Android to work, and I try to use like that library. And my knowledge on iOS was trash at that time, still. So I totally talked with a friend that is iOS developer and asked him to create the part on iOS. But obviously, those libraries solve the same issue, but every library makes on its own way. So what recommendation you have, for example, when I try to do a data bridge to try to be seamless integration to my plugin?
So you mean you have the Android part which is ready, and you want to integrate an iOS part, but the API so fast isn't the same?
At the end, make the same. I want to check if I am connected. But the Android says, okay, you are connected, but also you have a Wi-Fi. Or the iOS one just tell me you are connected, but not. But
okay.
You are in a network that you don't. So how you complement those instructions?
I see. So, for instance, if you have an enum on different kind of connectivity, you have different way of doing it. Either way, you take like the most information. So for instance, if Android gave you like connected or not connected, and iOS give you connected, great connection and bad connection, you can do that and map Android ones to the better one, even though it will be less precise. For instance, you say if it's yes or no on Android, you say yes is good connection all the time and no is no connection, and you have more information on iOS, or you do the other way around. So you take the iOS information and you degrade them. So you take, okay, it will be just yes or no, and I will lose the information of good or bad information. Like you have to make a choice. I think I'll do map Android to iOS if iOS has more information. But sometimes, for instance, like for permissions, Android and iOS doesn't handle permission quite the same way. So you often have maybe to have another call that the user will have to make, even though it will be like painful, but sometimes you don't have a choice. Yeah. Okay. Well, if you have any more questions later, you can find me at the Flutter booth. I'll be happy to answer them. Thank you.